This is an interesting question to have a go at, because if you don't tackle it the right way, if from the beginning you make the wrong start, you're going to get 0 marks. There are lots of marks that are depending on the first mark. So take the habit of starting such question by a bit of inspection. What are the things to watch out for? Number one, you have here, it's not cot theta, it's cot 3 theta. So spot that you have a 3 theta here. Check whether it's consistent for every trig function, trig ratio that we are using, whether cosec is also 3 theta. So clearly you're not going to need to use your compound angle formula, you're going to need to work with 3 theta. So we are going to adjust the interval that you're given. So theta is in degrees, I need to check that my calculator is on degrees, and if I have 3 theta will be between 0 and 540, 180 times 3, so that's 540. That's the first thing. The second thing is the trig ratios that you have here. You have a cot squared 3 theta and you have a cosec 3 theta. You need to know that there is a trig identity that link the two. If you know it by heart, then great, but make sure it's accurate. If you're not 100% sure, what I tend to do is I rewrite them, I find them again from cos squared x plus sine squared x equals 1. I want a cot squared, therefore I'm going to need to divide. The denominator will be sine squared, so I'm going to divide everything by sine squared x, giving me cot squared x plus 1 equals cosec squared x. What am I going to substitute in this trig equation that's given to me? I can only substitute the trig ratios that are squared. So therefore, I'm going to keep the cosec and I'm going to change the cot squared using the identity. So making cot squared the subject, that's going to be cosec squared x minus 1. And you need to watch out if you do it from memory, because very often we are used to the fact that if you change cos squared x into sine squared x and vice versa, it will be 1 minus the other one. Whereas if you use the year 2 trig identities, it's the other way around. Here you have cot squared x, it's cosec squared x minus 1. So it's the reverse order from what we are most used to from AS. But I'm now ready to substitute. So I'm going to have 2 times, and the replacement for cot squared 3 theta will be cosec squared 3 theta minus 1, and equals on the right hand side 7 cosec 3 theta minus 5. Expanding brackets, I'm going to form a quadratic trig identities. So that's going to give me 2 cosec squared 3 theta. I'm going to move the 7 sec 3 theta to the left hand side. So I now have minus 7 cosec 3 theta. And if I expand the bracket, I've got 2 times minus 1, so a minus 2. And I'm going to move a minus 5 from the right to the left. Therefore, it's going to be minus 2 plus 5. And this gives me plus 3 equals 0. So this is a quadratic. You could factorize, you could use your quadratic formula. Here it doesn't tell you which method to choose, so frankly you could use either. And these days, the more recent questions, they say show every step work algebraically, etc., which means that they will want you to show the factorizing preferably. So to factorize here, I'm looking at a times c. That's going to be 2 times 3 is 6. And then this is the product. B is minus 7. So the two numbers I'm looking for that multiplies, that have a product of 6, are going to be minus 1 times minus 6. So ready to now factorize. I do it my way. I always do it a little bit slowly because this sort of question gives me time for it and I don't want to mess up. So cosec theta plus 3 equals 0. So I split the middle term, and then amongst the first 2 terms, I can factorize 2 cosec 3 theta. And just to be a bit quicker, I know I'm going to factorize something, so I leave a space already. And the first 2 terms, if I factorize 2 cosec 3 theta, I'm going to have 1 cosec 3 theta left minus 3. And then for the second half of the equation, I will just need to factorize -1. And that will give me the -1 cos 3 theta minus 3 equals 0, which means now I can solve. So the two possibilities for cosec 3 theta is going to be a half, or cosec 3 theta is going to be 3. And at this stage, we need to remember that cosec 3 theta is 1 over sine 3 theta. So I'm going to take the reciprocal of both sides, giving me sine 3 theta equals 2, where this has no solution. And I write it for the examiner. And on the other side, this gives me that sine 3 theta equals a third. So that one will give me some solutions. I now get my calculator out, and I'm going to start working with my principal value, which is arcsine or sine -1 of 1/3, and my calculator is saying that this gives me 19.471, and that is a value that I'm going to keep because it is between 0 and 540. I leave a bit of space, but I remember that this, by the way, is a 3 theta, so I'm going to need to revisit and then divide everything by 3. But first of all, I want to find all my solutions. The second value will be 180 minus the principal value, and that gives me 160.529, but I didn't write the 0 over 60, and remembering that that's 3 theta, and it's within the interval, so I'm going to keep it. The third value is going to be the principal value at 360, which gives us 379.471, which we can accept. And then the fourth value is going to be the second value plus 360, and that gives me 520.529, which is within the interval that I'm going to accept. And I can see here that if I add 379 plus 360, I'm going to be well beyond 540, so I'm not going to bother. The final stage here is all of these values are for 3 theta. I'm going to divide all of them by 3, giving me theta equals 19.471 divided by 3 is 6.5. For the second one, 160 divided by 3, 53.5 to 1 decimal place. The third solutions I found divided by 3 gives me 126.5, and the fourth solution will give me 173.5 to 1 decimal places. And I can see that I'm within the interval of 0 to 180 as required by this question. And finally, I would then write out all of the answer for the examiner to make my answer very clear. So the possible value for theta will be 6.5, 53.5, 126.5, and 173.5. And that on this question is what's required to get 10 marks.